Today I am going to talk about Leibniz, German philosopher and mathematician who developed integral and differential calculus. And more specifically, what I'm going to talk about is an error made by him. So the problem where he made the error involves throwing two dice and getting 11 and 12 probabilities of these two events. What he states is that with two dice it's equally likely to throw 12 points than to throw 11, because one or the other can be done in only one manner. In other words, he claims that the probability of 11 is the same as the probability of 12, and they are both equal to 1 over 36. Now I'm going to explain how I think Leibniz came to this wrong conclusion. You can see on the left the sample space. We have 36 possible outcomes, and only one of them gives us 12. That is when we get 6 on both dice. So before moving on to 5 and 6, I should mention that using the facts that I have mentioned, we can find the probability of 12. That would be 1 divided by 36, which is the number of total outcomes. Now moving on to 11, we have two outcomes that can give us 11, 5 and 6, and 6 and 5. I think Leibniz did not distinguish between these two, and he took them as one. Therefore, he got the same probability as we did when calculating 12. But this is wrong, and now I will explain you the correct solution and then give you another approach to this problem. On the left you can see the same sample space. I modified it a bit. Now instead of showing pairs, I'm showing the sum of the two dice. Again, we have only 1/12 in this table. It is marked with red color on the distribution table as well, and from this we can get the probability of 12. That's again 1 over 36. Now, when calculating the probability of 11, we shouldn't make the same mistake that Leibniz did. We should see that these two outcomes are different, and we should take it into account when doing the calculation. That is, we should add these two separate outcomes. 1 plus 1 divided by 36, and this gives us 2 over 36. As you can see, these two results are not the same as Leibniz claimed. Now this approach is a bit different. It involves taking a single die and throwing it 2 times in a row, instead of taking 2 dice and throwing them at once. We know that these two events are independent, and therefore we will get the same result as we did in the previous approach. Now the sample space includes only 6 outcomes, and you can see from the distribution table that all of these outcomes have the same probability. If we want to calculate the probability of 12, we would take the probability of getting a 6 and multiply it by again getting a 6. In both cases we have 1 over 6, we multiply it by 1 over 6 and we get 1 over 36. Now say we want to calculate the probability of 11. In this case we have two possibilities. We either get 5 and 6 or we get 6 and 5. As you can see, I have calculated their probabilities and added them together. We add them because they cannot happen at the same time. We will get only one of these possible outcomes. The result is 2 over 36 again, as we got in the previous approach. And again, P of 11 is not equal to P of 12. That's it. Thank you very much. I hope you understood the error that Leibniz made and the two possible approaches to this problem. Thank you very much.